audience members, thank you for showing up. If you haven't been to one of our Two Scientists podcasts before, my name is Parmveer and I am the host. David usually hides in the background, taking pictures somewhere and trying not to get recorded on audio because he doesn't like his accent. And yeah, it's been a while since we recorded anything because pandemic, and we've been tired, and we're pretty sure everybody else has been tired. And in the meanwhile, we are in the midst of, I don't even know how to describe the current US elections, other than anxiety inducing. And so we thought we'd distract ourselves by talking more about elections. And so our guest today is Thomas Weighill. How are you doing, Thomas?
Yeah, I'm doing all right, thanks.
Yeah. So do you have like a kind of like a pandemic, what's the word I'm thinking of? Some kind of defense mechanism of choice. So I just started running again recently.
Yeah, I think that'll be it for me. I started jogging, although I'm not sure you can call what I do jogging. It's sort of about the length of about 3 of my favorite songs. But that has really helped. My sort of internal anxiety gets soothed by the notion that I can't possibly be sick if I can run X amount of distance every day, which I'm sure is hopelessly flawed. But that's, yeah, I try to go for a run most mornings. And in general, it's that, and I've completely switched to whole foods from like, I used to go to like the proper, we have this place called Market Basket, which is a traditional, awesome place to buy everything you could ever want. And I'm ashamed to say, since the pandemic started, now I'm like purely buying from Whole Foods. So I'm getting all kinds of, I'm eating a lot of kale salads and things, but something
each to their own, I guess. I mean, yeah. I think we're getting more takeout than ever before, but like I say, coping mechanisms. So the point of today's podcast is to talk to you about kind of how you got into maths specifically, where you studied, and a little about your research. So tell us your kind of mathematician origin story.
Sure. Yeah, I've worn a couple of different hats in sort of, I guess, STEM fields over my life. So I guess my exposure to math that's fun, as opposed to math you have to do, goes back to when I was in South Africa growing up. I got exposed to the Math Olympiad training stuff. So I think this is a thing sort of throughout the world, where, from sort of high school ages, folks get together and you practice on these kind of fun math problems. So it's not like adding big numbers or solving quadratic equations. It's cool stuff like, if I draw these triangles and these circles, what happens? And eventually you sort of progress through the ranks. And if you get selected, you can go to the International Math Olympiad, which is a big deal. Like a lot of extremely famous mathematicians got their start there. My advisor was a gold medalist at IMO in the States. Yeah, so I kind of got exposed to math there, and I went on math camps, which was extremely nerdy, and I have the t-shirts to prove it. Absolutely adored that. And then I immediately went to do engineering at college in South Africa. And essentially because I didn't think I knew that a mathematician existed. Like, I didn't know that you could just do math as a living, that math was kind of the thing that you could use to make money by building bridges or building robots or whatever. And I enjoyed my time studying engineering. This was at a place called Stellenbosch University. So I consider it to be a very good engineering degree. Had a lot of fun. Realized I was much worse at all the non-math stuff than I wanted to be. I was sort of, I would sort of do okay, calculating everything out. And then if you put a soldering iron in my hands, you just needed to get well away from me because something bad was going to happen. So that was kind of what I was doing officially. During that time, I met someone who would eventually be my master's advisor. He was sort of mathematician in category theory. And I think that like, if you talk to mathematicians, sort of professional math folks, there's like a common denominator. Their story is that there's someone who grabbed them at some point in their career and convinced them that math was like their calling, and like really showed them math is not advanced calculus. It's not just doing bigger integrals. It's this amazing exploratory thing that you can live in, and that you can just, it's so this thrill that you get. And for me, that was my master's advisor, guy by the name of Zurab Janalitsa, originally from Georgia, the country, not the state. And yeah, and so I started taking classes with him, as did my wife. The only math class I ever took with my wife, she promptly got much better grades than me. But nonetheless, he thought that I was good enough. And then I kind of had a decision point at the end of my undergrad to either carry on to doing engineering things, to do some kind of like, it was weird, some kind of cross-disciplinary data stuff, or to do math stuff. And I decided to take the funding of the second one and combine it with the actual research of the third. So I managed to convince essentially a media company to fund me to do category theory, which is abstract math. It's so abstract that abstract mathematicians are like, no, come on, really. I sold them on this idea, and yeah, I'm happy to sort of chat about that environment, but it was not good for mathematics, but it was free coffee and foosball tables. It looked like the inside of Facebook. They had clearly decided they wanted to build this kind of crazy looking lab. So I did a master's thesis in this sort of really abstract realm, gesturing at some applications to real world stuff. And then I came to the US, to Tennessee, to do my PhD. And again, I kind of had a couple of options. I was exploring sort of more applied stuff, having sort of done a lot of abstract stuff. I ended up settling on doing a PhD in basically geometric topology. So studying spaces, again, like really abstract, like not stuff that you would want to sort of talk about over the dinner table and say, well, this is helping us fight wildfires or something. But I loved it. I thought it was great. I had a lot of fun doing that. And then when it came time to sort of end the PhD, I looked around, went on the job market. Anyone will tell you that's a soul-crushing experience in academic mathematics. You know, sort of the cost we pay for having the best job in the world is that there's not that many positions out there. But one of the sort of most attractive options was with Moon Dushan, who's my current supervisor, my current PI at Tufts University. And I'd met her twice before at conferences, and kind of just really been blown away by sort of her career track and what she's been doing. So she has been extremely well respected in her sort of pure math field, but then she kind of made this pivot into thinking about gerrymandering, redistricting, voting rights, and sort of completely revolutionizing the mathematical theory in that area. And I thought like, it was, I mean, to me, it wouldn't have been as surprising or appealing if someone from, say, statistics or sort of some analysis people had been doing this, because that's kind of a natural modeling progression. But for someone who was doing what I was doing, which was geometry and topology, to make that change, that really caught my eye. So I applied and I got the position. I started my postdoc last year in July. And I very, very, very quickly learned a lot about redistricting and gerrymandering, because I was very invested in the topic, but I didn't know much to start with. And that brings us pretty much up to today, where right now I consider myself someone who does geometry and topology, and I'm still trying to get papers published, which are just pure mathematical imagination, abstract stuff. But I spend a lot of my time thinking about how topology and geometry can inform the way we think about data. And if you're going to do data science, you should have a pet. You should have some interests that motivates you. And right now, that is redistricting and elections, basically. Yeah, so that's a long walk from high school to where I am now.
Yeah, it's a great foundation, because actually I was going to ask you a bunch of those questions. So you're one step ahead of me. But one of the things I'd like to ask is, obviously, since we're talking about the subject of gerrymandering, and neither of us are originally from the US, and this was a very foreign concept to me when I moved here. I'm sure there's some version of redistricting elsewhere. But can you explain what it is, and actually know if it occurs in other countries?
Yeah, that's a good question. So just to frame it, so the US in particular, but some other places, elect people to governance by taking your geographic region. So if I'm Pennsylvania, I want to elect 18 Congress people, and you draw some lines and you divide it up into 18 districts. Each of those 18 districts sends one person to Congress. And gerrymandering is sort of the fact that, or the sort of the technique whereby you realize that, who draws those lines matters a lot. So, you can think about some examples of this, but basically it turns out that how you draw those 18 districts can make a difference on any given day as to like who gets elected and what kind of party affiliations they have, right? So it turns out that it's this sort of obstruction, I like to think of it, from people expressing their will at the level of government, right? Like folks are going to the ballot box, just want to vote for someone who represents their interest. But if people are messing with the way you can vote, then you sort of disempowered from being able to. I'll be honest, I'm not an expert on gerrymandering in a lot of other countries. Where I come from in South Africa, we have party list proportional representation. So that means you go to in this country, that would be you go down, you write Democrat or Republican, then you walk out. And then the Democrats and Republicans fill Congress with whoever they want. And, the debate between that and districted systems is so old and belongs to so many people that aren't me, that I won't try and sort of state anything affirmative. I'll just say that, the standard arguments against and for are that with districts, who your representative is, right? Like we can all phone our Congress people. We can get them on the phone and talk to them. Whereas if you're voting for a party, well, unless you happen to know the chairman of the party, you might not be able to access the person that you elected. But on the other hand, we just spoke about gerrymandering. Of course, with proportional representation, with party lists, you eliminate that completely. Britain has a bit of a history with this. Like some of the earliest anti-gerrymandering stuff was to do with the fact that there weren't population bounds on what you could draw. So Britain would do things like draw a little parliamentary region which had 3 sheep and 2 people and elect someone and send them off, there is a skit in Blackadder, which this always makes me think of, but I realize this TV show is not as well known in this country, so I don't employ it as often.
It is on Netflix, so people should go and watch it.
Oh, great. So I think it's whichever, I think it's the Regency Blackadder, if that's Blackadder 3, I think.
Yes.
Yeah, in other countries, what's more common is either this kind of proportional representation, or you have sort of, I guess, like multi-member districts sometimes. So you have a district with more folks being elected, and that tends to like ameliorate some of the issues. If there's more people being elected from each district, you have a better shot at like something like proportional representation. And in my very limited experience, you tend to get more proportional results with that. But again, I'm kind of treading on ground that really belongs to political scientists and sort of whom I'm very happy to collaborate with, but I don't pretend to be one. So yeah, that's not perfect answer, but that's something.
So do you know what the inspiration behind the group was?
Yeah, so Moon kind of got willingly dragged into the whole thing by a good friend of hers who basically convinced her that mathematicians needed to weigh in on this issue, because at the time, very little was understood about this issue. Like folks have been drawing lines for ages, but we hadn't reached the stage when data and computation had caught up to the point that you could say concrete things about it. Like you could look at a map that someone had drawn like literally by hand and say things about it, but no one was going to be able to use a computer to sort of simulate stuff based on it. And the original focus, I think, of a lot of her work was to do with district shape, was to do with, so, I mean, this is an issue that at some point we're going to discuss because this comes up in gerrymandering, so I might as well say it now. A lot of folks think of gerrymandering as ugly districts, districts that look terrible. So these windy things, like anyone from Maryland knows their district looks this terrible snaky thing. Pennsylvania had a district called Goofy Kicking Donald Duck for a while, which is a pretty accurate statement. And it turns out that two things are true. One is that there are reasons to have weirdly shaped districts that have nothing to do with nefarious intent. And two, that you can draw lovely looking districts and get exactly as much advantage for your party. Classic example of this was in Pennsylvania, where there was this Goofy Kicking Donald Duck situation, and the Republican-controlled state Senate, I think, floated a plan on Twitter that looked gorgeous. I think it looks gorgeous. I love it. But if you ran the math, it had exactly the same electoral outcomes as Goofy Kicking Donald Duck.
Huh.
And so this was simultaneously a bit of a crushing revelation, I think, in the sense that we thought that we would just be able to apply some nice discrete geometry to how much is it curving, how weird is it? And but it actually blew the door open to this, like, okay, what are we dealing with here? How do we even begin to understand this problem? Moon sort of like, and I don't envy her for this at all, like deep end exposure was consulting for Governor Wolf in Pennsylvania during the redistricting mess that happened in Pennsylvania. And realizations like, okay, we need to draw some maps. Where is the data? And the sort of legislature responding, well, we won't give it to you. I think they said this in court. We won't give this to you. Also, it doesn't exist. And sort of the shock and horror realizing, wait, hold on, you're telling me we don't know how people voted in Pennsylvania? Like, no one actually knows. Those kind of things. So yeah, basically it started with this idea of, okay, we're just going to measure shapes, and it just blew up to be so much more. And then she started this group. Initially, this group was kind of like a early Microsoft kind of couple of kids in a garage kind of situation, doing amazing work. And to this day, I don't understand how they got done what they did back in those early days. But then sort of we found a nice home at Tisch College in Tufts University. We're able to actually, hire some people on sort of some kind of decent term basis. And now we're this research group. I like to think of us as probably the leading research group, although I'm probably upsetting some folks. I'm allowed to be biased. It's my research group.
Absolutely. So from a very practical point of view, for me, like this is the kind of math that my brain can compute, because once it gets to abstract, it's just like I have no idea what's going on. But for me, this kind of applied mathematics makes a bit more sense. So how is it that you, what does it look like for you to do your research?
Yeah.
Remember, I'm a biologist and I do experiments for a living.
Experiments. Yeah, we do experiments as well. Our experiments consist of, so we don't do 1,000 assays, we do 1,000 redistrictings of Pennsylvania. Well, actually we do 1 million redistrictings of Pennsylvania because computers are awesome. Yeah, so like our central business is answering questions about redistricting and gerrymandering empirically using computational methods. So to do, and what I'm super interested in is, I'm sort of interested in two different things. I'm definitely interested in like, how can we make an impact? Like that is a question that has to be answered. And often you kind of have to put your ego to the side there and realize that like the simple intervention you can make is the one that will work, right? Like maybe what you want to do is, apply persistent cohomology modules to this problem. But really what you need to do is just add those two numbers. And if they're big, there's a problem. Like sometimes you need to, put aside what you like to do. But I found that like this area gives rise to tons of unexplored questions that are emblematic of a lot of data questions we have right now. And so for me on a day-to-day basis, what I'm trying to do is take sort of the new wave of mathematical data science and trying to find ways to both exploit that to solve the problem that we might have, or to inspire something from that problem. To give you sort of a concrete example, I said we did 1 million redistricting plans for Pennsylvania. Okay, so you can ask a number of questions about that, but the question which interests me is, what does the average one look like? That's kind of, it turns out to be like a fun and complicated question, right? It's not super obvious what you mean by average, right? You draw a bunch of different maps, and this maybe someone's in this district in one of those maps, then they change districts, but the districts don't come with God-given numberings. There's no district 18 because you just drew a map. You didn't say where district 18 was. And so you've got to find a clever way of saying, what's like the basic central tendencies, right? Can I point to a map and say with some conviction, yeah, there's usually 2 districts there, one there and one there, and that one's always Democratic. That's the kind of insight that I would like to mine from the millions of maps that we generate. And it turns out to be a super fun problem.
So I was looking on the website, and the group is quite big. What are other people doing, and how are the various ways that people come to approach the problem?
Yeah, we're big and we're multidisciplinary. We have data scientists, geographers, we have myself, which I guess is a mathematician / data scientist. And we have essentially folks who are really into programming, and we have people who are just at the intersection of all of that. So we've got a number of projects on the go right now. And, as usual in a research group, people kind of find things that interest them, and we all discuss what's needed on which projects, and we all kind of generally just driven by our interests. But one of our big projects is something called districter.org, which is a website where you can draw maps. And this was sort of, again, developed by someone in the early days initially. Again, a huge lift that I don't know how they did, but now is in active development. So we have 2 software developers, I think is what we would essentially call them, plus a geographer working on that sort of every week, adding new features carefully, sort of turning and also trying to figure out like what is the market. When I say market, we're not making any money of this. I mean users, right? Like you won't see an ad for anything anytime soon on Districter, but sort of how can we bring this to communities? How can we let people play with this in a way that matters? Our data scientists are sort of involved in a bunch of different projects. Right now, we've got a project where we're studying election reform, which is sort of, it's kind of a natural spin-off from our gerrymandering work. So I just discussed that like you can elect people by district, or you can elect people proportionally. Another way to do it is to come up with an alternative voting system like ranked choice, which is on the ballot in Massachusetts, actually, which is sort of a more sophisticated way of electing folks. And I'm sure some people have heard of this and maybe have strong opinions about it. Our work is about how do you predict when that will be a good option, especially for marginalized communities. And so a lot of I think I'm working with one of our data scientists, Dara Gold, on this project, along with a geographer who used to be with us, is now at grad school, named Ruth Buck. And that's been a very interesting project to consider. That's a classic case where the math is such a small part of the battle. Like as any good math modeler knows, it's like you've got to think very, very hard about the context before you press a button on any computer and just simulate stuff and let it go. Yeah, so that's some of the stuff that's been going on. We also got, I will mention, brought into the fight against COVID a little bit. We're currently also in-house developing the app that Tufts uses to do the testing scheduling for. And so this is for COVID on Tufts campus and a few other places as well. And this was basically a case of someone, I think the president of Tufts, realized that so we were a sort of a treasure trove of geospatial data science skills.
Yeah.
And he was like, you know what, I'm gonna put these people on the case. And we all learned a lot very quickly about basic epidemiology and queuing theory. I think it's been pretty successful, as a venture. So we get up to a lot of different stuff. Yeah.
It's very cool. Actually, it didn't occur to me, but it makes a lot of sense given that one of the key things that we're having to adhere to is physical distancing. And so it seems like
physical distancing. I think for us, it was a lot to do with also like in geographic space, how do you manage the load amongst hospitals and different facilities? And how do you model like where are the vulnerable populations? When are they coming in? You can take a roster of like, okay, which states are students coming from? What's the rate of infection in those states? What should we expect day one? What should we expect day two? These are all like, this is not gerrymandering, but this is, we have the skills and we have the team to be able to handle some of those questions.
Very cool. I mean, that's a lot bigger than what I was thinking in terms of just having people spread out. So you mentioned earlier that you don't make any money off of the site that you were talking about earlier, but David is sitting over there sending messages. He wanted to know, are people like you hired by political parties with the intent to maximize their political fortunes? This is a bit like white hat hackers versus black hat hackers.
Well, I'll tell you, I haven't had any offers, but my impression is that I don't know. I think it's possible that they are, and I don't know about it because it's so under the radar. My impression, just from the very couple of things I've seen, because we do have transcripts of certain things, is that the political parties and the line drawers are not quite where we are in terms of the research. Like, they're catching up. I think that they are going to have to adapt pretty quickly to a scenario where we have the ability to scrutinize a lot of what they're doing when they're drawing the lines. I'm sure there are folks up there who get called as, say, expert witnesses for various sides, and some of the best work that gets done in this area is by expert witnesses. One of the earliest things the MGGG did, that's our group, rolls off the tongue, is went around the country training expert witnesses to talk about fair redistricting, to be able to stand up in court and say, this map is fair or this map is unfair, and why do we believe that? So, I have a tremendous amount of respect for the work those folks do, sort of fighting the fight in the courts, right? Because we write the papers, but we're not on the front lines necessarily. We try to support folks like that by training or by providing resources. But I'm not aware of any black hat gerrymanderers out there. And I can't, people sometimes ask, like, so we have an algorithm, can I use your algorithm to gerrymander? And my general response is no, you really can't. Like, our algorithm is very good at figuring out what is a typical plan. It's not great at drawing a plan, like some specifications, at least not much better than most people are. Like, I don't know. I've seen people on Twitter post gerrymanders using our Districtor app, actually. They'll sort of say, look at this awful gerrymander of Michigan. So I don't think it's that hard to draw a gerrymander, honestly. I think that what's hard is putting and this is, the Supreme Court has been asking for this for decades and eventually just gave up, putting your thumb down and saying, okay, this is unfair for the following verifiable reasons. That seems that's the way more challenging question than just drawing an awful map, which people have been doing, since the word gerrymander was invented.
So thinking about this conversely, we watched Moneyball recently. And, at the end of the movie, what it comes down to is the fact that they've got this guy who is essentially using whatever models he's got to predict the best baseball team, right? And, the manager of the Red Sox says, by next season, everybody is going to have one. So is it possible that for the states, the local governments that want to do the right thing, that groups like yours could help with the redistricting so it was more fair?
Yeah, and we have been in that position before. We have, you know, we've spoken to a couple of folks. I think we were pretty in close contact with a group called One Virginia 2021, which was trying to bring about redistricting reform in Virginia. And there've been another couple of occasions where groups pushing for redistricting reform in states have sort of spoken to us and said, you know, can you give us some advice, like what's important? And so yes, absolutely. I think we have a duty and obligation, and we try to help in those kind of situations. We have close relationships with a couple of folks in sort of the independent redistricting space, and we try and sort of bring them in and sort of tell them about our point of view, like, and give them the tools to be able to analyze things. Yeah, I think that's absolutely the way we should think about redistricting research, is as empowering folks to drawing the lines. I don't think anyone in my group would advocate for computers drawing lines. I think there's just so many things wrong with that. It's a non-starter for various reasons. However, you know, more and more states are handing over line drawing to people, to citizens. This is on the ballot in Virginia, I think, and saying, you know, instead of making politicians draw the lines, we're going to make people draw the lines. And you know, if I was on a redistricting commission, well, that would be fun for me. But the average citizen, you know, has to do what I did in July of last year and learn a lot very quickly. Mm-hmm. And I think one of the best places we can serve people is by making sure that states have in place the resources that folks like that need. Simple things like data, like, you know, making sure that if a sort of a citizen who maybe has no experience with computers, no experience with data science, wants to say, hey, I want to see a map of Pennsylvania which shows me this, then that it's available to them. So yeah, absolutely. I think that's the goal here, is for our research and sort of stuff we do to inform policy and to improve the way we draw the lines. Yeah.
Nice. So we're getting some questions from other folks, but before we get to the one from Mike, I wanted to ask, why Pennsylvania? It seems to be the one that keeps cropping up.
There's a joke that I'm the Pennsylvania postdoc. To be honest, so there are a couple of states that have really been battlegrounds for this. Pennsylvania went through a whole thing where they had, I mean, there's a couple of reasons. So going through them, firstly, obviously, it's definitely, Moon was involved. She was in the fray of this whole thing, where the proposed plan in 2011 was awful, and there were multiple attempts to replace it. And it was a series of course battles between I think the League of Women Voters in Pennsylvania and the people drawing the lines to try and get a fair map for Pennsylvania. And I think they were successful in the end. I think the current plan, which is the so-called remedial plan, drawn by a special master, so this is someone who comes in externally and draws the plan for you, typically a college professor, I think is a really good map, at least compared to what we've looked at previously, and we have the data to back that up. But my sort of obsession with Pennsylvania, I think, comes from the fact that I wrote a book chapter which is going to come out next year. We've got a book coming out, folks. It's called Political Geometry. Berkhouse is going to publish it at some point next year, and in it it's a fantastic book. It's just a sweep of various different academic insights into redistricting. So we have stuff on law, stuff on political science, stuff on math, stuff on sort of on the ground folks who are actually dealing with this. And in that, I wrote a chapter which sort of beat Pennsylvania to death data-wise. Like, I think we looked at every possible election we could find, and for the last sort of 4 years or so, And every single way of drawing districts, from districts which are normal sized to districts which are like half this, like tiny little guys. So I think we went from what if Pennsylvania had 3 districts to what if Pennsylvania had 220? And we ran every single number. So I've just got pages of like excruciatingly deep dive on every possible perspective on Pennsylvania. So yeah, hotbed of gerrymandering, really bad data, ironically, despite my obsession with it. And for some reason, it's just a interesting case. I guess another thing to say about Pennsylvania is that it tends to lead to disproportionate outcomes. So Democrats are never quite able to get as many congressional seats as like, so Pennsylvania is 50-50-ish, okay? It's like a purpley state.
Yeah.
Democrats in the really gerrymandered plans got hammered very badly. Often the Democrats complain that they can't elect enough Congress people out of Pennsylvania. And what's interesting is that if you sort of run the algorithm and you run the numbers, that sure, Democrats shouldn't do as bad as the worst gerrymanders out there, but your sort of even plans drawn by a neutral computer don't tend to award Democrats quite their proportional share. So this is a nice little mathematical puzzle. It's a puzzle to think about. Why is that? Well, you can say some easy things like, well, Democrats tend to cluster in cities and this is bad, but you peel away at that and you start to get in sort of to much more complicated territory of, what is it about that that's bad? So I've given you like 4 or 5 reasons why Pennsylvania for some reason keeps coming up. I can't, if I think of any more, I'll let you know.
They all seem legit so far. So the question from Mike was, can we discuss the utilization of math to determine the degree of gerrymandering? So his background included the navigation routines of optimizing lunar excursions of the lunar excursion module.
Okay, that is extremely cool. Like, yeah, so the engineer side of me that cries during Apollo 13, that is very impressed by that. So let me roughly sketch that out quickly. So you've got a map in front of you. The first thing you can figure out is if everyone voted the way they did for Clinton and Trump, who would win and by how much in each district. That's something you can do if the data is there. As we said, it's not always there. But let's suppose we're in a nice state like North Carolina, which has gorgeous data. It's wonderful. Okay, and now you have to decide if it's gerrymandered or not. And you have a number of different choices. One thing you can do is you can try and set up a clever formula for how did the party do, and without really considering where you are and what's going on in North Carolina specifically. And so there's a couple of these. There's efficiency gap, there's partisan symmetry, mean median scores. These are all basically ways of looking at the districts and how many people and sort of the vote shares, like how people voted in those districts, and making a one-time determination on how like middle of the road fair is it. And so this has been sort of accepted by a number of places. The courts have sort of been iffy on it. I mean, the Supreme Court eventually didn't accept anything, but they didn't like this. And our sort of main, I guess not objection, but sort of the main criticism against that is that you're really not taking into account the specific case, right? What if it's the case that the efficiency gap in North Carolina is usually 0.1, no matter how you draw it, but in some other case it's minus 0.1 or something, And this is not idle talk. We do have a paper which is a little bit of a hot take. It's pretty spicy, but we've checked the math that sort of pokes holes in a lot of these traditional classical ways of just looking at numbers. So our approach is slightly different. What you do is you say, okay, we know how you drew the lines and it seems pretty sus. So what we're going to do is we're going to generate every other way you could have drawn them. And we're going to see how you did compared to that. If you managed to give Democrats more seats than every other plan we drew, well, it sounds like you were engineering something there. So either you got very lucky or something was going on. And so, okay, where's the math? Well, the hardest question is, what about these all other plans? How many are there? It's more than the number of atoms in the universe, that's for sure. So you've got a bit of a problem. You can't possibly enumerate them all. And in fact, you don't want to. Most of them are horrible. Most of them look terrible. I mean, they make goofy kicking Donald Duck look beautiful. So you've got to think, like, what is a good representative sample of desirable maps to compare against? And that question is, that's what keeps us up at night, is even though I think we've got a really good algorithm for it, like that is the big question, is sort of, how do you go about doing that? And we're not the only folks doing that, by the way. There are other people like Wes Pegden, and Jonathan Mattingly in North Carolina, who are also doing this kind of stuff, right? Where they generate huge numbers of different plans and they do this stuff. And so we're not the pioneers, but we have our special sauce, our algorithm. Its name is Recom, stands for recombination. And I think it has the advantage of being something you can run on your laptop, as opposed to something you have to hand to a supercomputer. And so far, it's proven very, very useful as a way to detect gerrymanders. So, and I refer to these as ensemble methods. So ensemble means you've generated a bunch of different plans and then you look at specifically that one. So yeah, that's our point of view. And that's sort of the background as well of what other folks are doing in this space.
So we also have a question from Jack, which is, when you're working with this kind of data, what is the spatial resolution? You mentioned that you were looking for an average map, in inverted commas. You saw that some regions always turned up democratic. Is it possible to make a political heat map of a region?
Yeah, so that's a really good question. So a political heat map, or geographers call them choropleths. So you can take your state and you can try and look at, where did Democrats vote, where did Republicans vote, like. So a state we haven't spoken about a lot is Pennsylvania. So in Pennsylvania, Philadelphia and Erie and Pittsburgh and Scranton, these places are really blue and everywhere else is red. Okay, but how do you actually see that? Well, we don't know how each person voted, fortunately. Fortunately, the US democratic system is strong enough that we don't have access to that data. All we know is, at some level, we know how the votes were collected. Now, if you see a picture of a state and how it's voting on election day, say, coming up, you're probably seeing it by county. You're probably seeing, like, this county went for Clinton, well, in this case, Biden, and this county went for Trump. But there's a finer grained level you can go to, which is precincts, voting precincts. And so these are sort of, and if you have actually voted in this country, you probably know what your precinct is. It's kind of like, it might have one polling place, might have more, but it's sort of the way that they're going to tabulate your vote, right? It's the region. And so one of the best ways to visualize things is just to look at precincts, map of precincts, and color them red and blue, depending on which way they went. And that'll give you some kind of political heat map. And if you stare at that for long enough, you can sort of gain some insights from that. You can try and go lower. You can, because districts aren't always drawn out of precincts, which is annoying. Sometimes districts are drawn cutting precincts in half. Not all states, some states do. We wish they would all respect precincts, but they don't always. And then you've got to make some fun statistical decisions about how do you guess sub-precinct vote totals. And there are a lot of ways to do that. And that's sort of a whole field in its own, basically. It's sort of, okay, I know how people voted in this big unit. How did people vote in the smaller units? So you can go lower at some cost. But what I think is a super interesting question, and what motivated some of my research, was you can look at this political heat map of red and blue areas, and then you can draw districts. And when you draw districts, it's kind of like you're almost like losing quality in your video. You're compressing the data, because now you've got maybe 2 blue cities and you put a district right on top of them. Now they're bound together. They're going to vote for the same congressperson. So the big question is, okay, you've got the political heat map, you can look at that. How does the subtle variations there translate into who wins big districts. And that question is kind of hard to answer. And so when I sort of when I say something like in the average plan, this district always goes for Democrats, it's not about looking at the map and finding blue. It's about finding the right size of blue to fit neatly into a district. And that's kind of hard to predict beforehand. But fortunately, if you draw enough maps, you can gain that kind of insight.
So we were looking up your future on the website, and it says that you're going to move to North Carolina. And given that you're doing that, are you going to carry on doing this kind of research?
Yeah, I fully intend to. I'm very excited. I'm going to be joining UNC Greensboro, which is, yeah, I've known a few folks down there from like my days in PhD. So I was super thrilled when I got that position. Yeah, North Carolina's a great place. I mean, we spoke about Pennsylvania being our hotbed. North Carolina went all the way to the Supreme Court. It's definitely a place to be. And as I mentioned earlier, their data is gorgeous. As bad as Pennsylvania's data is, North Carolina has done a great job at like just putting it all out there for folks to play with. So we love North Carolina. We hope they love us back. And yeah, absolutely. I think redistricting is going to play a big part in sort of the way I think about mathematics and data science going forward. I think that it is worth saying that I think gerrymandering research has a lot to teach us about other data science methods, right? I often sort of discover problems that I think someone must have solved this, but they haven't in this space. And so what I'd love to be able to do is some kind of translational stuff as well. Sort of, okay, I solved this problem because it was interesting to me in gerrymandering. Who else is doing this, right? Maybe folks in image recognition are interested in this kind of technique. That would be that's an important goal of mine as well.
Yeah, so in general, the fields you were talking about, David mentioned category theory, which means absolutely nothing to me, but can you explain where else that kind of work is applicable?
Where category theory is applicable?
Yeah.
Well, they try very hard not to be. I think category theory is interesting. So yeah, I think it's worth saying that mathematics gets inspired by real world problems, and then it often kind of goes off on this wide sweeping imaginative loop in history, right? And the sort of the arc of the universe seems to be that it comes back and pays off in a big way. So, people are working on Riemannian manifolds for 100 years just because they like them. And then Einstein comes along and turns it into the sort of foundation of physics all of a sudden. So a lot of math gets done because it's beautiful and it's interesting and it's curious and there's the chance of a big payoff, but it might not happen today. And category theory has some applications. I think there's a book now on applied category theory. I think some folks are using it to model database systems. Some people are using it to model some logical systems. I know John Byers is someone that folks may know. He's sort of has a pretty sort of high profile in the math community for turning category theory into something that actually has an impact in various ways. But to sort of justify it that way would be selling it short a bit. Category theory is really about understanding deep mathematical facts that tie all mathematics together in this sort of beautiful abstract framework. And as you're doing that, you're streamlining mathematics, you're building new connections that no one saw, and you're creating this sort of these beautiful theorems and beautiful results that down the road are going to be the way that we understand things. As an example for my research, a lot of what I spend a lot of time thinking about is topological data analysis. So that's data science, but the stuff we're using was invented in like the early 1900s by some French guy thinking about imaginative space. Like he was thinking about the Klein bottle, which is a space that curves back in on itself in 4 dimensions and then does something weird. Spaces that you or I have never encountered on the street because they just don't fit into our imaginations, let alone the real world. He was trying to understand those things, and that kind of that obviously shot off into this huge field we call topology today, and led to vast insights. And physicists have been using it for crazy things like superstring theory. But like in the last 10 years, maybe 15, people have been saying, hey, like, this is great stuff. We should look at data this way. You know, Poincaré in his French office was thinking about shapes. Well, let's think about shapes, except instead of thinking about imaginary shapes, let's think about data and like what shape of data is. So that's a 100-year arc from something that, you know, students now learn in classical topology courses to something which is being applied and sort of giving machine learning techniques a run for their money today. So yeah, so I think a lot of math can't be justified in the sense of what I did today will impact tomorrow, but it's no less valuable for that, in my opinion.
Maths always sounds nothing if not romantic.
Yeah, we do tend to wax lyrical about mathematics because I don't know. I mean, if you I think it's true that most mathematicians are in math for the love of the subject. Because, you know, there's lots of other ways we could be applying the sort of skills that comes with mathematics, but we just absolutely love the thing we do. But I will say that it's not true. I don't think it's like everyone should love math, but if high school or school ruined math for you, then that's more about high school and school than it is about math. Like there are huge chunks of mathematics I was taught that I have no love for. I'm sorry. I have my greatest sympathies to the people who have to teach and the people who do love first year calculus. But I don't get out of bed in the morning going, boy, I really hope I have to do a U substitution to solve this integral. No, I don't like that at all. What I like is sort of this crazy, imaginative, problem-solving, abstract thinking thing that happens, this alchemy that happens when you are doing like pure mathematics. That's great. And I think it's possible for pretty much anyone to experience that joy. It's just that, you know, sometimes we don't have enough time in our lives to, you know, to do these kind of things, or it gets just beaten out of you in school. You get taught multiply these 5-digit numbers. That's what math is, and it doesn't go anywhere from there.
I think that's true for so many subjects, though.
It could be,
but
yeah, I think maybe history is one of those as well, right? History at certain, maybe they've fixed it. They were trying to fix it when I was growing up. That, you know, because history used to be this date, that date, and this happened and this happened. That's not what research history is about at all. History is about understanding people and events and the context of everything and learning from sources. Same with things like English literature, right? Like English lit is not, you have to read the Scarlet Letter by Tuesday. I have a good friend who's a Hemingway scholar, and she spends her life sort of combing through Hemingway's letters, trying to figure out where any of his kids were at any time. And it's like detective work. It's awesome. Like I could see myself enjoying that if I had those skills. Like I could see myself getting a kick out of that. Didn't particularly care for all the stuff I was made to read at high school.
As a callback to Blackadder, that's essentially the only history I got in high school, was because my teacher decided we were going to watch the last season, which is set in World War One.
Oh, that's such a sad one.
I know. But still, I mean, it probably beats most forms of teaching history, as you mentioned earlier. So going back to the subject of US politics, and that's essentially what we've spent a lot of time talking about. Has your research impacted anything about how you see US politics?
Oh, that's a nice one. That's a good question. It's hard. In a little bit, it's hard to answer that question a little bit because my increasing awareness of US politics ran sort of parallel to my involvement in it as a research topic. I think, yeah, if there's sort of, I'm trying to think of sort of one pithy insight, but I guess something I've sort of realized is that it's nowhere near as simple, and that looking at it in a quantitative way, you're often tempted to do that. Like, you know, we often simplify things in mathematics to, you know, Democrat or Republican, or we talk about Voting Rights Act, and we sort of look at a district and we say, okay, the district is 52%, has 52% Black population, therefore it's effective for representation for Black voters. And, you know, this is sort of like the mathematician's way of looking at things. But if you spend any amount of time staring at the problem and actually talking to folks, you realize how much nuance there is. This comes up a lot in our work on election reform. So we like to talk about ranked choice voting a lot, and we like to run the numbers and say, ranked choice voting does this, and districts would do that. But at the end of the day, nothing about that will change the mind of someone who says, you know what, I like to know where my representative lives. I like them to live on my city block. And I don't care if your math models say that in some abstract sense we'll get more representation. That's my buy-in to democracy. That's how I want things to go. So I guess my main insight would be that we need to be careful of, you can call it a quantitative fetish. We need to be careful of trying to put binaries and numbers on things, and ignoring the local context of what's going on, and that there's absolutely still a place for people to do the hard work of understanding, for this very specific community in this specific scenario, you know, what is at play, you know, talking to folks and you know, getting beyond just surveys and poll results. I don't know, maybe that's a bit of a generic answer, but I think that's I think that's a reasonable way to summarize.
Yeah, and I mean, people are just so very complicated. Like it seems like it would be difficult to try and solve this as a math problem without speaking to people as well.
Yeah, and not that there aren't people trying. I think there's a lot of people who are trying to remove the human element from a lot of the stuff we've spoken about today, like redistricting. Like, I think for a lot of folks, the answer is if you give a computer enough objective functions and press the optimize button, you'll get the perfect map and we can all carry on with our lives. That's not our point of view, and it would never be our point of view, because we're a multidisciplinary group. We have partnerships with people like civil rights organizations, and you know, we're too embedded in the problem to think of it as just a mathematical exercise. I mean, we bring what we can to bear, and I find the cold hard mathematics that comes out of it endlessly fascinating, and I like to play with that. And that's, you know, I definitely get up in the morning wanting to do that kind of stuff. But it's a big point of pride for us that we try and take the human sort of the human factor into account in all of this, because ultimately at the end of the day, it's about handing power back to voters and getting them engaged in democracy, not about an elite academic class telling folks this is how democracy should look and this is how you should go about voting and go about your representation. Yeah.
Okay, so I'm cognizant of time, and I appreciate you have a small human that your wife has been trying to get to bed. But we have a couple more questions.
Sure.
We've got one from Mike, who says, can typical factors such as employment types or educational histories determine political leanings about which to organize optimum outcomes?
That is a big question. I think that question belongs to political scientists a bit too much for me to say too much about it. There are sort of definitely sort of tried and true statistical methods to determine those kind of questions, right? But the problem comes down to the unit problem, as it's everything is kind of being viewed through a mirror darkly or whatever. It's through this aggregation up to precinct level. For example, one of the hardest problems in political science, but sort of data-driven political science, is if an election takes place, and you want to know, did people's race play a role in how they voted? That's a really hard question to answer because we have the secret ballot, right? You can't take the ballots and go, okay, here's someone's race and here's who they voted for. And you'd think that the way, sort of the flippancy with which this gets talked about sometimes in the media and in places, that it was a done deal. But you kind of have two choices. You can either try and do some kind of surveying or exit polling or whatever, which is fine and has its own biases that they'll admit to. But if you want to learn it straight from the data, you've got to learn a lot of statistics. And it turns out to be a super fascinating space because every day in this country, there are folks standing up in court testifying about this racial group voted this way, this racial group voted this way, appealing to some pretty subtle statistical models behind the scenes. So I'll say that our group is actually super involved in this space. We're currently trying to develop a Python package for doing this kind of analysis because it's historically been in the language called R, which is fine. It's totally fine. It's just everything else we have is in Python. So we'd like to keep everything in the one language. So that's kind of a roundabout answer to the question, rather than saying, oh, yes, and here are the relationships. I'll say that it's pretty hard in general because of the secret ballot, which we should, to be clear, absolutely still keep, no matter how much data scientists might want it. It's a pretty hard question and requires some careful kind of modeling decisions. Invariably, you end up treating people of diverse ways of thinking about the election. You end up treating them very sort of simple, in a simplified fashion, in order to make your model work. And you've got to account for that at the end of the day, because you could be wrong, and the question is by how much.
So yeah, it's not all about you, data scientists.
Yeah, yeah, well, I think so. Yeah, I don't know if folks know, but for the first time this year, the census is going to mess with the numbers to add noise to it. And this is also something that, so you might have -2 people living in your apartment by the end of the process. So it turns out that the way the census has been doing things for years is totally hackable. Like you can do tricks like realize that in this area there is exactly one female head of household person of this race or something, and then it's a privacy concern. So what the census is instead going to do is like mess with all the numbers a little bit, but then they mess with it again to make sure that there aren't -2 people in your apartment, okay, at the end of the day, and that it all adds up to the right stuff. And a lot of folks have a visceral reaction to this. They're like, no, what? No, you can't do that. You can't count people and then change the numbers. Data scientists are totally on board. We're like, the numbers were wrong to start with. Come on. Not, there's measurement error. Just, it's fine. We'll be fine. I mean, we'd honestly be fine with -2 people in your apartment. Like it goes into the computer just fine as a number. Computer doesn't know. That's impossible.
In voting terms, I mean, we can't vote anyway, so we may as well be -2 people. So the last question is Jack, who is fishing for free career advice. He says, as someone who has studied mathematics in a variety of fields, both abstract and applied, what advice could you give for an undergraduate who can't decide on a single research area going into graduate school?
Who can't decide on a single research area and is going into graduate school?
Yeah.
That's totally fine. Though you don't need to know, you don't need to know what you're doing when you're going to graduate school. I would highly recommend against narrowing yourself down at that point. I'm assuming that this person used the word grad school, so they're talking about the US. Mm-hmm. So in the US, one of the great things about grad school is that you walk in with, generally, you walk in, you don't quite know what you want to do, but you get to try a bunch of classes, you pass some exams, you see what you like, you find an advisor, you go from there. So no, yeah, absolutely. Walk in, see what you like, see who sort of you connect with. It's been my experience that mathematics and it shouldn't be, but it somehow is. It's a lot about people. It's a lot about like you had this one teacher that the way they saw things was the way you wanted to see them, and their field was something you were sort of vaguely interested in, but watching them talk about it, that made you suddenly have this like deep insight, and you're like, I want to learn that. I mean, that was with me with category theory. I didn't know what category theory was, but just the passion that my master's advisor had for it, and the way he exposed to me how beautiful this was, I thought, okay, this is absolutely something I want to spend my time doing. So yeah, going into grad school, don't worry. In terms of the applied pure split, maybe I'm being a little bit glib by saying you don't need to know whether you're pure or applied at all, because there are some schools out there who will be who will divide it and say there's applied and there's pure. My point of view is probably still just go in with your arms wide open, get whatever you can. It's all great. It's all super fun. Grad school is a great time to just take a course in something that you never think you'll use, and expand your horizons that way. And I've changed research fields basically 3-ish times. No, let's say 2-ish times. And it's a bit scary when you do it, but it works out. It's great, and you kind of get a head start on your colleagues for what you lack in basic understanding. You kind of get a head start because you know this weird other field they've never heard of. So yeah, that's my answer to that question, and I hope it works out.
Yes. So he says he's very relieved, and in the meanwhile, David is trying to reassure him he wants to work in Math Onco, which is where David is based. And on the subject of being impartial, this question's too good to pass up. So Austin asks, I understand that MGGG is non-partisan. How do you navigate questions about your political views when presenting your work?
Yeah. I think we are very careful to be non-partisan. We don't take money from Dems. We don't take money from reps. We are primarily NSF funded. And we do occasionally, we partner with voting rights organizations who are sort of, so their mission is to just make sure that people are being represented and people aren't being denied the chance to vote. And so it is a point of pride that we are nonpartisan. When it comes to your political views, I don't know, this is a tough conversation to have. I think that we definitely have values and principles that we stand for, we're not ashamed of. We certainly I wouldn't sort of be shy about stating some of the values that we hold as an organization. But in terms of our partisan leanings, my approach is always to try not to bring it up in sort of research contexts. But if you get me down the road at the pub, well, I'm so sorry, I'm talking about the before time. If one day you get me down the road at a pub in a better world, then I'll happily share with you all my thoughts about what's going on. Although I do try to temper it with the fact that I'm not a US citizen, so it is a race I can't directly influence by voting. And it's also, I wasn't born in this country, I didn't grow up here. So I try not to center my own voice too much in those kind of conversations. Yeah, it is a bit of a sticky wicket, doing research in a political science arena. But I think that the key thing is, we have our values. We stand up for voting rights of minorities. That's a non-political issue for us. We want to see the Voting Rights Act enforced, and we want to see people be able to elect people who represent them, regardless of sort of whatever minority status they might have. Those kind of non-political points we're very clear about. And then when it comes to partisan support, maybe that's for the pub after the seminar.
Yeah, one would hope that that's the kind of thing that no one has any particular argument with, which is that if you're an American citizen and you meet all the stipulations, you should be able to vote, right?
Absolutely. I think there's, and we're talking about gerrymandering, there is vast bipartisan support in the public for proper redistricting. Like no large portion of the public is really on the side of, we should gerrymander for my side. Like I think I've seen a poll to this effect, but it's something I just believe in my bones, that at the end of the day, you know, people want their party to win, but they're not interested in, you know, the way they can vote and who they can vote for being controlled by a sort of some people that are up at the top, right? Politicians shouldn't pick their voters, voters should pick the politicians, all that stuff, you know. So in terms of anti-gerrymandering stuff, I think we're talking to everyone at that point.
Very cool. So before we let you disappear, what was your dirt story?
The dirt story. Okay, I was trying. The best I could come up with was, it's something I'm not sure it's very interesting, but it was embarrassing, so that counts. So now I'm trying to work a lesson into it. So how's that for a sleight of hand? I was switching from my master's to my PhD. I just arrived in Tennessee from South Africa. I was switching fields from category theory to essentially topology. And so I thought, you know, I was kind of used to going to a conference a year, at least, to sort of a big conference a year. And so I thought I have to do something to get myself motivated, to sort of make sure that I could go head first into this new research area. So I applied for and got into a conference in Switzerland, which was a bit of a wild ride because I was pretty much flat broke at that point, and they didn't like buy the tickets for me. They were like, we'll reimburse you afterwards. So that was a lot of fun. Yeah, I guess the one of the reasons I was broke is coming from South Africa. I saw my paycheck and I thought, I'm rich beyond my wildest dreams. And then I saw the grocery prices and I realized, oh wait, these two things go up together, don't they? But I was in Switzerland and I was at this topology conference in Lausanne, and I only knew a couple of people there, but the people I did know were category theorists. Now, category theorists have a bit of a reputation, which is completely undeserved, of occasionally thinking they're a little bit better than everyone else. So category theorists will sort of category explain to people sometimes, you know. So someone will come up to them and say, here's this really specific thing in my field, and they'll say, that's just an example of a, you know, quasi-coherent sheaf over this infinity category. You know, like your bit of knowledge is subsumed in my knowledge. Again, completely undeserved, this reputation. But the people I knew there were two folks from category theory who I think are straight geniuses. Like if one of them wins the Fields Medal, I will not be surprised. And the other one actually left mathematics to go and make huge amounts of money for some firm, I think. But these are people that were sort of just above my level, maybe the same level as me career-wise, but to whom I just like looked up to. But I was hanging out with them, so I was kind of at the cool kids table because I knew category theory. So we were all chatting a little bit. And at some point they said to me, can you believe there's people at this conference who don't even know what singular homology is? And I have this rule, and I will advocate this rule, that I never pretend to know something in mathematics. And it has, I think it pays off long term. And I was sitting there and I was like, I could just keep quiet or I could speak up. And so I said to them, well, I mean, I don't know what singular homology is, expecting them to sort of brush it off. And there was about 2 minutes of quiet. And then they like sort of ummed and ahed a little bit. And I tried to repair it by saying, oh, well, I mean, I know the general idea. It's like it's the maps from this space, right? And they were like, yeah, sure. And that was the last time I spoke to those folks at that conference, I think. I think I'm exaggerating a little bit, and I hope that they don't think unkindly of me for telling the story. But I did definitely feel like I'd lost my membership to the Cool Kids Club because I didn't know what singular homology was. But I did eventually learn what it was, so I'm cool again. No fear.
Very good. Thank you so much. We really appreciate your time. Honestly, the conversation was fascinating. Is there anything are you kind of consuming all the political information, or are you desperately trying to ignore it right now? Because it feels like the next 2 weeks are an eternity.
I think everyone has some kind of IV hooked up, right? So I think for me, it's Twitter. I have Twitter hooked up into a vein somewhere, and I can't stop the drip of what's going on. I guess I have an interesting perspective because coming from South Africa, you know, we understand pretty well. I think a lot of US folks take for granted that democracy and everything that goes with it is this unshakable rock of Gibraltar. And you know, in South Africa, we have a very young fledgling democracy with a lot of problems and a lot of victories as well, surrounded by places like Zimbabwe where things have really got tough. And so it's an interesting perspective to sort of not just assume everything's going to work out okay. And what I always try and look at is sort of what is the strength of the institutions, like the media, like the courts and other places like that, sort of, and how are those structures going to hold everything together when things get shaky at the top. So I guess I am following it with some trepidation. I certainly hope that my daughter has, you know, a bright future because, you know, she was born here. She's a US citizen, and I hope that the future is really bright, at least for her sake. And I don't know, I'm trying to be optimistic, and there's not much I can do about it because I can't go to the ballot box. But you know, we'll do our best to help in the ways that we can. But you know, we're not the frontline folks. We're sitting doing research and we're trying to contribute in our way. But the people who are really doing the job are on the ground, organizing and sort of working in communities. And those are the people I have huge respect for.
Yeah, absolutely. And as you say, it's great for those people out there, given that we also cannot vote. So in the meanwhile, we're just going to drown our sorrows.
Well, I've got ginger beer, so I'm not quite there. But yes, cheers.
That's okay. Thank you again so much. Really, really appreciate it. It's been an absolute pleasure. And we'll give you a shout at some stage when this is all released and up on YouTube. And you can feel free to share with your friends, should you so wish.
Oh, I definitely will. This was a lot of fun, and I think y'all are doing a fantastic job. You know, bringing science. I think science communication is, especially in this day and age when anti-science is a thing, and folks are getting a bit mistrustful. And you know, if we have another hour, we can talk about how, like, this isn't all not our fault. Like, you know, we in the academia have some of the blame there, but I think that folks like you guys who are doing the job trying to engage the public in science, it pays dividends for everyone involved. So yeah, keep up the good work is what I'm saying.
I certainly hope so, and I appreciate you saying that, because yeah, a lot of us in SciComm are despairing right now. But yes,
no, like I say, just keep going. You're doing the right thing. I think we'll get there.
Will do. All right, thanks again. Have a good evening.
Take care.
Bye. Thanks everyone for joining. We'll see you around.
Bye everyone.
Bye.